Hi class, you guys just watched a video about the 5 different forces we have in our class and their directions. I'm now going to go ahead and give you 6 example problems so that you guys know how to draw a force diagram. Let's quickly review what you guys learned in the last video. There are going to be 5 forces. One is Ft, that's tension, that's a rope force. One is Ff, that's friction, and I forgot to mention that can also be air resistance for our class. We have Fa, which is a person or object that's pushing or pulling on something. And then we have F of N, which is a normal force, which is a surface force. And then we also have F of G, which is gravity pulling straight down. I don't think I gave you those abbreviations, the Ft, the Ff, the Fa, the Fn, and the Fg, but that's how we're going to write it just to save ourselves some time. I'm now going to go ahead and solve these 6 examples for you guys, and just follow along. You're going to have those forces in front of you. So these ones that are above here, you'll have on your note sheet in front of you. And although I can go much quicker, you might need to have those 5 in front of you, kind of like as a checklist to go through for all these problems. And eventually you'll get through them really quickly and they'll be very fast. Number 1 is a skydiver falling. So the reason why he's falling is because gravity is pulling him straight down. On the video that you just watched, it said to draw a dot for the object. I'm actually going to draw the force diagrams like on the actual person or object. That's actually better. I've changed my mind in recent years. So you can go ahead and draw it literally like right on the person or the block or whatever the object is, like I'm doing here. So we've got gravity pulling down on that skydiver, but there's also air resistance pushing up, and we consider air resistance to be a friction force. If you ever wanted, you could write F of air, but I'm going to write FF all the time. But if you want to write F of air, that's fine as well. And that's it. Nobody's pushing him. There's no rope force. There's no surface. There's no Fn. So it's just those 2 forces on that person. I'll go to number 2. A person sliding to a stop is going to have gravity pulling him down. The surface is pushing straight up on that person. And he's sliding while going to the left, which means friction is the opposite way parallel to the ground. So that's that friction force right there, going to the right, the opposite way that the person's going. There's no rope, so there's no tension force, and there's no applied force because he's not pushing himself. He's just sliding to a stop. Nobody is pushing him. So that's an important concept there, that even though he is moving to the left, nobody's pushing him at that moment. Therefore, there is no applied force. As I go to number 3, somebody's pushing a block. The forces on the block will obviously be gravity pulling it down. The surface is pushing up on the person, which is straight up because the floor is level. We see that person pushing to the right on the block, so that would be Fa. And then the ground and the block interact with each other. So even though the person pushes the block to the right, we know eventually if he lets go of it, it'll slide to a stop, which means friction is pointing the opposite way down here, which is Ff. So those are the 4 forces. In fact, you're only going to ever have 4 total. You'll never have all 5. That's the situation where you have all 4. In this next one, we have a block sliding down a ramp. Gravity always pulls straight down. Even though I know it's going to slide down into the left, it's sliding down into the left because of the angle of the ramp. If that ramp just disappeared before we let go of the block would just fall straight down. So don't get fooled. Gravity always pulls straight down no matter what. Friction is going to be the opposite way that it's sliding. So if it's sliding down into the left, friction is going to point up and to the right to try to slow it down. And there's a normal force, and the normal force, sorry for the bell there, the normal force is going to be perpendicular to the surface. Now on flat ground, that would be straight up. But since it is angled, we have to have a 90-degree angle right there with the surface. So that would be Fn. And you can see with this little blue line, it makes that little 90-degree angle right there. So on angled surfaces, you are going to need angled normal forces. 2 more. 2 kids are pulling on Mr. J's bag of candy. Well, the force diagram on the candy would be somebody pulls to the right. That would be an applied force. This person's pulling to the left, that's an applied force. Gravity pulls down. There's no tension force really. There's no ropes pulling on it or strings. There's no normal force because the dum-dum bag is not on the ground. So it's just the two people supporting it, pulling it opposite ways, and gravity pulls down. If you wanted to say there's some sort of friction on there, I guess that'd be okay between their hands and the bag, but you don't have to put that. And the last one is a sign problem. Sign problem is actually easier than you think. Gravity is going to pull down on that sign right there, so that's Fg. There's no normal force because it's not touching the wall. It's not on the ground or anything like that. It's hanging up in the air. So there's no Fn. There's no friction because it's not sliding or anything like that. So the only other force left would be maybe applied, but nobody's pushing it, so that's gone. The only thing left would be those two strings right here that I kind of put in red right there. So the rule is you just point the arrows away from the object. So this string, although the sign wants to go down because of gravity, this string is pulling up with it. And then this string over here on the left that's horizontal, that's trying to pull the sign to the left. And you would just call that Ft because that's a rope force or a cable. And you would point that one to the left because you just have to, for sign problems, you just redraw the rope and just point the arrow away from the object, and you'll get the direction of the force right. And again, there's no friction because it's not sliding against any surface, and there's no normal force because that sign is not touching the wall. Okay, knowing that, I think you should be off to a good start. Try your best, and I will go ahead and check that worksheet I gave you for homework tomorrow. Thank you very much.